All right, data management. All right, so we're going to talk about the topic of data management, and what we'll do is, this is kind of a long lecture, but we're going to have a bunch of lab exercises at the end. So maybe what we'll do is we'll talk for something less than about 30 minutes. We'll find a nice break point, take a break, and then we'll continue with the lecture. And then at the end of the afternoon, or the end of the morning, we'll work on some lab exercises, okay? All right, so data management. Let's talk about the things we can do. All right, we're going to talk about utilizing some tools that ultimately utilize the Web Services API. So these are tools which we have developed. They are actually written in other languages. They don't run on the platform, so they're Windows tools that allow us to do integration with Salesforce using the Web Services API. So the tools themselves, like I said, are simple client programs, but the mechanism by which they communicate to Salesforce is via the Web Services API. All right. So we're going to talk about record IDs, common data management operations, why would we be doing this stuff, and the different formats of IDs. All right, so one of the things that Universal Containers needs to do, and this is common amongst all organizations, is that Universal Containers either has legacy systems or existing systems that they're planning on keeping around that they would like to keep in sync or possibly migrate data over from into Salesforce. Okay, whether it be paper forms, spreadsheets, some sort of some other database, whatever the data store is. Okay, so that's what we're going to talk about is data management, so integrating data from other sources. So what are some types of things that you would be doing? Well, you might possibly want to export data for the purpose of archiving it for backup or maybe some sort of regulatory compliance. You could insert data. Maybe you are doing some migration from some legacy system. So one of the things that we want to do is maybe get a list of users from, for instance, a directory server or something like that, and we want to generate users within Salesforce. Or possibly we have a list of positions already in some other system, for that matter, candidate information, and we want to populate the Salesforce data with that legacy data. Updating data. Things like deduplication, so maybe we're looking for duplicates. We could also do something, think about record types. Maybe a year from now we decide to implement record types on candidates. Well, we're going to have a bunch of candidate records in which the record type field is empty. So maybe we want to export our candidate information, maybe run a little program that comes up with some determination as terms of, if this is equal to this, then let's set the record type equal to this. If it's equal to that, let's set the record type equal to that. And then we would then update the existing candidate records with our new record types that we set. So we'd go use the Salesforce record ID and then go up and introduce record types into our data by performing those updates. Okay. Deleting data, so maybe we are simply reducing old data, or reducing the amount of data, the size of our data storage by freeing up disk space by deleting old records or archiving them or something like that. Or maybe those deduplication, part of deduplication is getting rid of the record that is the loser. So. All right. So record IDs. Salesforce has record IDs. And Salesforce uses these record IDs to uniquely identify records, or to identify unique records. This is the primary key that we utilize in Salesforce for your records. There are two formats of record IDs. There is the 15-digit format, and then there is the 18-digit format. But as I'll show you, those two are related, and you can actually calculate. They're just two formats of what is ultimately the same thing. Okay. Anytime that you create a record, so if you perform an insert, it's going to generate a record ID. Record IDs are created by the database. They are not created by you. You cannot, for instance, go out there and decide, oh, I want to set the record IDs. Always generated by the database. Okay.
Question.
Yes.
Is that an encrypted number? I mean, that format sort of looks.
No,
I think it'd be a numeric
not.
Value. So it's an alphanumeric.
It's just an alphanumeric key. In fact,
It looks randomly generated.
No, it's not. It is not randomly generated. You will often see, for instance, that if you create 5 records, you'll see that the last character is incrementing by 1. So it's not a random number. There is some algorithm on the back end which is going, okay, here's the 51st record of whatever type, and here's the 52nd. So they differ by 1 character at the end of the day. So it is incrementing that. It's also another thing about these is that the first 3 characters are special. The first 3 characters identify the object type. Okay, so that A00 is associated with a record type within your system. Okay. I'm not 100% sure about this, but I think A00 is an account. It's a universal code for accounts.
So the latest key is kept somewhere in the database, so that it will keep on incrementing. The latest key that the database uses is also kept somewhere in the database then.
I would imagine so. Yeah. Somehow it's. Yeah, or somehow, it's completely, it is completely hidden to you, that logic. I don't know the logic, but over on the database somewhere, it is, it has a table that's going, okay, these are the used IDs, and so it knows not to generate one with that already exists. Now, how it's keeping track of the last one or whatever it may be, I don't know how that works. So don't make any assumptions. Like I said, that often you will see, it's like, okay, here's, blah, 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 record A, and then blah, 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 record B. Don't necessarily make the assumption if you insert 15 records, it's going to be A through M or whatever the first 15 letters of the alphabet are going to be. Okay. So just the general rule is don't make any assumptions. So that being said, if I click on accounts here, I'm sorry, accounts is 001. I think the first custom object that we would have created would have been A00. So you'll see A01. So let's go to recruiting. So 001 was accounts, and let's see if I click on job applications. This is A02. A04 is interviewers. A01 is candidates. So the point I'm trying to make is not that, I guess the point I'm trying to make is that the first 3 characters are associated with each of your object types in the database.
Can you please hover over the records so we can see the ID?
Oh. So if I click on one, what I'm looking at, by the way, so let me show you what I'm looking at. I'm looking at the URL at the top of my web browser. And so when I click on a tab, notice that it says salesforce.com and then /A01 and then slash, and then it looks like a lowercase o. That must be sort of a starting point indicator. But the A01 is that 3-digit code on the front of the record ID that identifies the record type. If I now click on a specific record, notice that my 15-digit record ID is what's displayed after salesforce.com, and notice that it starts with A01. Okay.
So those first three are unique to the object?
Yes, so those first three are associated with an object type, yeah.
In different applications, can there be two different A01s, or it's all unique to the whole system?
Well, applications are just a user interface element. So candidates exist everywhere within your org. Yeah. Okay.
If we had multiple orgs, could it have the same ID? Okay.
Yeah.
So we'd have to be careful. Say this org plus this ID.
Yeah. So for
unique.
instance, we each have different orgs, and yet we're all going to have A01s and A05s.
But the IDs are unique across the system.
You know, I think they are unique. Let me research that.
/ and then the ID.
Yeah, but it's also taking into account your cookie. I think they are unique across the organization. Let me check on that. I've heard that before, but that's one of my...
I think if you go to the next record, the only difference is the last 3 or last 4, something like that.
Yeah. So if I go back here and take a look at the last one, it's probably going to be awfully similar. Yeah. All right, so let me check about the uniqueness of record IDs across orgs.
And that's like case sensitive, right? So if you change capital G, it won't find it.
It is case sensitive, so good question. So the 15-digit IDs are case sensitive IDs. Okay. So so I'll look up that uniqueness across orgs for the actual record ID. But let me continue in my slide because we're going to talk about the different types of record IDs. All right. So the IDs can be obtained in a number of ways, but some of the places where you'll see them are, for instance, in the URL, like I just showed you. In a report, you could create a report in which you could display the IDs. You can also see IDs in things like the Web Services API. For that matter, running Apex code, you can get IDs. I'm sure there's other ways in which you could see those IDs. So, all right. There are 2 different forms of an ID, though. Okay, there's the 15-digit case-sensitive form and the 18-digit case-insensitive format. Okay. When you're using reports, or for that matter, the default for the URLs, when you enter in those are the 15-digit IDs. Now, anytime you're doing API stuff, or for that matter, if you're writing Apex code and you're programmatically selecting the ID, you're going to get back the 18-digit ID. Okay. Now, why do we have 2 versions? I'm not entirely sure about the history of this. I believe that they originally started with 15-digit case-sensitive IDs, and then they created the 18-digit versions, which were case-insensitive. And the reason was that customers who are exporting their data, certain case-insensitive databases or systems would automatically convert the case, and then they would attempt to load it back in or perform an update on the data, and it would not find the records or create new ones because the record IDs did not match. Now, like I said, it's not like a record has 2 IDs or 2 keys. All this means is that there is a 15-digit ID, which is case sensitive, and the 18-digit ID, the last 3 characters are generated based on the location of the uppercase characters in the 15-digit ID. So assuming that we can perform conversion, of an 18-digit ID to a 15-digit ID really quickly. Chop off the last 3 characters of the 18-digit ID, you now have the 15-digit ID. Okay? Assuming you did not change the case on that 18-digit ID. So assuming you did not convert the case, so assuming our 18-digit ID is in the proper case, to convert it to a 15-digit ID, just cut off the last 3 characters. In other words, the first 15 characters between a 15-digit and 18-digit ID are the same. Now, to generate an 18-digit ID from a 15-digit ID, it's a slightly complex thing, and just so you understand the algorithm, this is not something that you need to do per se, but the last 3 characters identify where the uppercase characters are in the 15-digit ID. And so what you do is you break the 15-digit ID into 3 chunks of 5 characters. In a binary format, you assign a 0 for a lowercase or a number, and you assign a 1 to an uppercase letter. Then what you do is you flip the order of those now 5-digit binary numbers, and then you calculate a single character to represent what is now a 32-digit binary number. So what we do is if it's 00000, we assign that to A. If it's 4 zeros and a 1, we assign that B. So on and so forth until we run out of letters, and then we start the numbering. And when we get up to that 32nd character, we assign that a 5. Okay, or I'm sorry, 32nd number, which is 11111. Okay. Then we take those last 3, or those 3 generated characters, and we append them onto the end of the 15-digit ID. Okay. Now, do you need to do this? No. The API, the Web Services API, accepts, and for that matter, your Apex, accepts as input either the 15-digit or the 18-digit ID. So it's not like you're going to have to write a lot of code to do the conversion. But I just wanted to explain to you what that is, the sort of the algorithm behind that. So those last 3 characters identify the uppercase characters in the 15-digit ID. Okay. People have also, out on developer.force.com, people have posted code samples in different languages for if you wanted to write a little program that did the conversion for you. Like I said, the API accepts both, so when you're sending it back in, it accepts both. The API outputs 18-digit, but it accepts both as input, so you don't have to convert to get it back in. Okay?
But if we created a data, let's say we created a data warehouse, right? Pumped everything over. We could get one record with 5 lowercase I T, and then we get another one 5 uppercase I T in our data warehouse. Or would we never get that? Because
in terms of output, the Web Services API is always going to give you the 18-digit ID. So we never did. The thing is here, in the URL, we see the 15-digit ID. We'll also, if we wanted to display this on a report, we'll see the 15-digit ID. But in terms of programmatic mechanisms, you will see the 18-digit ID. Okay. Yeah. And then you can also take the 18-digit ID, and I can't do this off the top of my head, but if we took the last 3 characters, we could also, in the URL, I don't know why you'd want to do this, but you could enter in the 18-digit ID in the URL, and it would accept that. So.
Doesn't that make everything a little bit more confusing for the debuggers, the developers that are using the API processes to see which record they are working with? You know, I'm talking thinking about the things that we do in regular life.
Yeah.
We usually need this key and need this record to see where we are.
Well, you know, the thing to keep in mind is that it shows up in that URL, but in terms of, like I said, programmatically, you're always going to get that 18-digit ID back. So anytime you're doing something where you're creating that integration or whatever it may be, that's what you're going to be dealing with. So yeah, this is definitely, I mean, I'm sure that if they could, you know, go back 10 years and redo this, I bet you know, if they would have predicted the problem that they ran into with the customers having the conversion occur, they would have created a system that would have been, it would have avoided that problem, definitely. Yeah.
So is there a way to see this in the interface? Is there in the user interface? Is there a way to see the record ID in 18 digits?
Well, there's a way I can do it. So one of the tools that's available, we don't really use it in this class, is the force.com IDE. It's an Eclipse plugin. So what I'm going to do is I'm going to use this tool. So here's my project, and what I'm going to do is there's something called the schema browser, and I can run a SOQL query. And so what I'm going to do is I'm going to select, I was looking at a candidate, right? So I'm going to select the ID from candidate where c.id equals like so, okay? In fact, that might not, there we go. So it turns out that the last, looks like A, B are, yeah, because the first 10 characters don't have any, oh, that would have been an easy one to calculate. Now that I think about it, the first 10 characters don't contain the uppercase letters, and the last 5 characters only contain 1 uppercase letter, and it's the first one. So that's B. So what we could do here is, for instance, we can do something like that. Notice that it takes me to the same page. Now, like I said, here I'm writing some code, which is a SOQL query. And so the database is always returning back that 18-digit ID. You know, if you did want to see the 18-digit ID, or, you know, you could run queries where you did, you know, select the ID from the table. Here I can get all my IDs. So, okay. Yeah.
The query that you did, it seems like it's selecting the ID from a candidate where the ID, so it's the same field that you're referring to, is equal to the 15 digit.
Yeah. Yeah, so I mean, if I wanted to, I could come out here and say where c dot last name _c equals Jane. So I could do something like that. Let's see here. Is there a field called last name? Let's see, underscore. There we go. Sorry about that. So for instance, here's the ID of the candidate with the last name of Jane. Am I answering the question?
No, I just thought that, or maybe I was misreading it. You were saying where CID is equal to the 15 digit and it gives you the 18 digit.
Yeah. Oh, because so that's the thing, is that was what I was trying to say about how when you are inputting or when you're requesting, for that matter, it will look at it and count the number of digits and go, okay, this is a 15-digit number, therefore I'm going to execute my logic for doing the lookup based on 15 characters. If I wanted to, I could say where c.id equals, and then I do AAB, like so. And then when I do, I'll do, let's see, last underscore name. So do something like this, and then here, this is George Schnell. But you know, I could have as a part of my query parameter either the 15-digit or the 18-digit ID. For that matter, if I'm doing an update, I could use either the 15-digit or the 18-digit. Okay? So, yeah. Mauricio.
It feels like this extra portion, it's an added feature when you are retrieving information from a legacy system, because somehow you can use this portion as a validation code. Mm-hmm. It gives you like a way to verify that that ID that you are receiving from that system somehow is the one that you are expecting, isn't it?
So the record ID allows you to validate
that extra portion, because somehow it tells you something about the ID.
Yeah.
So when you receive info from a legacy system, somehow you can validate that this ID that you're receiving is correct.
Yeah, I mean, it allows you, in the legacy system, you could write some code to identify where your uppercase characters would be if, let's pretend, you had a database full of 15-digit IDs. Is that, am I?
Yeah,
is that
what I'm
you're
saying
kinda
is
getting at?
when you submit it from Salesforce to a legacy system,
Yeah.
there's no problem because you're generating or supplying the correct IDs.
Yes.
But in the other direction, when you are receiving information from a legacy system, the legacy or the programmer may make mistakes and on the IDs.
On the Salesforce IDs.
On the Salesforce IDs.
Yeah.
So when the legacy is generating information to be sent to Salesforce, somehow you can validate that these IDs that legacy system is generating are correct via the extra portion, right?
So you're saying write some logic. So if you're doing an integration with Salesforce, you could write some logic. So if you get 18-digit IDs, let's verify that the last three characters match up with the uppercase characters in the, in the first. Sure. Oh, okay. Yeah. Yeah, I could see that. Just to make sure that it wasn't mangled in some way. Yeah. So it's a little almost like a, what do you call that? Checksum type. Almost. Yeah. Probably not.
So with that, you have to make sure that, I mean, that's okay for just checking the last three. Mm-hmm. But if they mangled something prior to the last three.
Well, if they, yeah, I mean, if they, the other thing is, yeah, it's not a perfect.
Change the case.
Yeah. But it could be used as a sort of a checksum type thing. Yeah. So.
Does Salesforce allow you to do that when you create a record? Tell it what ID to use?
No.
No.
No. So every record has both a 15-digit and an 18-digit version, but it's ultimately the same ID, just in two different formats. Okay.
So Salesforce stores it as an 18-digit ID on the back end.
Well, let me put it this way. It doesn't matter. All right. So what's that?
Those so-called queries that are stored, the actual ID is stored as.
It always. My point that I'm trying to make is, it doesn't matter how Salesforce stores it. What matters is here's what we're always going to return to you. So my SOQL query that I just performed, which I could have done that through a web services call, Salesforce will always return to me the 18-digit version of the ID. Now, it could be stored in Salesforce in some super secret 100-digit code in reality. Doesn't matter. What we do know is that every time we perform that query or we're getting data back from Salesforce, we're going to get the 18-digit version. Okay? Yeah. So.
Is there a limit of records that you can save into an object?
Limit to the number of records associated with an object. There are situations where, so the question is, are there is there a limit to the number of records of an object type? I know that for our very large customers who have millions of records of a certain type, so for instance, something like a phone book company who has their list of accounts would be large. So they have a ton of accounts. Now, everything's fine up until you run that report or that query, and suddenly you're looking across, 3 million accounts in order to find one, and your report is taking a long time to run. Now, in those cases, for our very large customers, there are alternatives in terms of the way that we are able to scale those very large customers, and that is handled on a one-off basis for the customer's needs. So they do special things for the large customers who are going to have millions of whatever. But otherwise, in your case, until you get to that size, that scale, it's not, it's not something that we need to sort of do special handling for. So, okay. So yeah, so for our very large customers, they go, okay, we set up some special stuff in the database where we run, I'm not sure how it works, but it does kind of like parallel queries type stuff. It uses some advanced database features to make the queries go faster. So how it works actually.
The main reason why I asked is just because in the 15-digit ID, the only difference is the last 4, and also there's some permutation that I don't know how big. So it's like numbers and then letters and then uppercase and lower. It's case sensitive, so I don't know what the permutation is. But so I think there's some kind of limitation if you that you're gonna run.
It's
probably very.
However,
big.
the number of letters in both uppercase and lowercase, and the number of one-digit numbers, 10, to the 12th power, so it's a pretty big number. So, but like I said, that's not the issue. The issue is when you run that report, it takes a long time to run, and they have special things that they do for our large customers to make sure that they have high-performance applications. Okay? So.
Do we archive records as well?
That's part of the solution. Is what some of the things that they do is they take a look at the application and say, well, do you need, for instance, cases that are more than 3 years old? Can we archive those to increase performance? So they work with our customers to utilize different techniques so that they improve the performance of those queries. So, okay. All right. All right, let's talk about relationships between objects. In our data model, we have relationships which enable us to have a relational data model so that we can segment our data and not have to store data redundantly in different locations. So for instance, candidates are related to job applications, and job applications are related to positions. Reviews are associated with job applications. There's a couple of ways that we see this. In the application, anytime we see a related list, that indicates that that object that we're looking at in the related list is a child, has a child relationship to the current object. The flip side of that is anytime we see that lookup icon within the UI, we're then navigating up to the parent. Okay? Now the way that we do this is in the database, we utilize the record ID to define the relationship between the current record and then the related record. So for instance, on a job application, there is a field in which we store the ID of the related candidate, and then another field for storing the ID of the related position. Okay? All right. What that means is that we now have dependencies within our data. If we're going to be doing some data migration, we could not load in something like a review, because the review, or I should say, we could not load in a review first because the review has a reference to a unique job application. If that job application doesn't exist in the database before that review is inserted, then it's going to result in an error because it couldn't locate the associated job application. So if we're going to load in a set of reviews into our database, the last thing we would do is load in the reviews, because the reviews refer to the job applications. The job applications have dependencies because the job applications have references to candidates and positions. Now our position also has a reference. The position has a reference to the hiring manager. The hiring manager is the user table, right? Anytime we're loading in data, we're going to need to do it in the opposite format in terms of, I guess it's not necessarily opposite, but you know, from parent to children in that order. Okay. All right. Okay. There is a feature called modifiable system features. Or I'm sorry, modifiable system fields. And this is one of my least favorite named items within Salesforce. And the reason is that no system field, or that these system fields are never modifiable. Okay. What they are is system fields are initializable. Okay. So let's talk about what these things do. Well, first of all, there's a bunch of system fields like created date, created by, last update date, and last update by. Let's say that we take a bunch of positions that already exist in some legacy system. By default, if we insert all of those positions into Salesforce, the created date is going to be today, and the created by is going to be the integration user that I used to insert those records. Well, I might want to keep track of the history of these positions, and insert, when I perform the insert, I want to say, okay, the created date was actually January 5th of 2006, something like that. So using the feature called modifiable system fields, we can actually set those for system fields in order to retain that history. Now, like I said, it's not really modifiable. It is initializable. In other words, when we're performing that insert, we can set these fields to be what we want them to be. Once we've inserted the records into Salesforce, they are no longer modifiable. Okay? So
is this something like before you load it in, you just put the date, what you want it?
You would pop, exactly. So the way you'd use this is that when you're migrating your data, you would actually, in the CSV file or the program that's going to call the web service,
add a column of create date or something.
Exactly. So make sure that you have a created date, a created by field, so on and so forth. So those 4 fields, you can actually set them up during the, or set values for those during the data load. Okay. Otherwise, other than being able to initialize these, they are always controlled by the database. Okay.
Is there any validation done on that data? Like if you put a created by for a user that doesn't exist on the system?
Well, definitely, because created by is doing a lookup to the user table. So it's going to reference a ID, a record ID for that user.
And if you don't supply those values, do they get generated for you?
Yes. So the default is the created date is today, and the created by is whoever the user you're logged in as. So, and then same with the last modified. So, yes, question?
So when you default it will default to that, but if it errors and it's, like say you populate with something that's not valid, will it then back up and go with the system, like go with your default?
Yes.
Or will error the whole
So the question is, what's going to happen upon error? By default, what happens is that whichever, let's say you have a position that's referencing a user that doesn't exist in your created by field, that record will return an error, and it's going to say something along the lines of ID not found in user object or whatever, and then that will not be inserted into the database. So, yes.
How about if I have a record, let's say position was created by me, and then someone deleted my name as a user?
So if we, okay, so we have an existing reference, and well, in that case, it's, I would imagine it's not going to let you do that. There's the situation, there's the behavior of the, the behavior of a master detail is that it deletes the children. The behavior of a lookup relationship is that it simply you'd have an empty field on the child. So it would disconnect that. But if we're talking about something like the created by field and we're deleting a user, let me test that out during the break. I'm not sure what would happen. I would imagine it's going to complain, but let me verify that.
I don't think you can delete users, right? You can just deactivate them.
Oh, true. You just deactivate users. Good point. So you don't actually delete users. You simply deactivate them. Yes.
But that brings up another point. So any kind of lookup context, if you delete the not parent, but the lookup parent,
yeah.
Does it actually nullify the fields, or does it just leave the existing value in there?
So if I deactivate a user,
not users.
Sorry. What then? What?
Other kind of lookups. So department lookup.
So if let's say I have a lookup relationship.
Say I have a department object and I have an employee object.
Okay.
Employees belong to departments. But it's a lookup relationship rather than.
Okay. Okay.
So if you delete the department.
Yeah.
Does the department field in the employee record get
I believe it gets blanked out, but let me we can really quickly verify that in a tool. So let's see here. What's a candidate I don't like? So a lot of these I use somewhat frequently. So all right, let's see. Let's find one that has a related job application. So here's a candidate. So Bonnie Rutherford has 2 associated job applications. So if I delete Bonnie, now, I should have gotten the, that was silly. I should have gotten the ID of the, all right, I'm going to recover Bonnie. So here's our recycle bin. Here's a demo of our recycle bin. I am going to, let's see here, not empty, but recover. Let's see here. Undelete, thank you very much. Okay, so let's undelete Bonnie. Now let's go back into our list. All right, so the one I want to look for is app 0008. Now let's delete Bonnie again. And we're looking for 0008. So and then the related candidate is blanked out. So Bonnie is no longer on that field. So yeah. It's, it's interesting that it actually then maintains the relationship when undeleted, and yet, so I'm not sure how that works. I don't know I can't explain that, but it did maintain. So even though this field is blank, when I undeleted Bonnie, so if I go back to my recycle bin and I undeleted Bonnie, and now if I click on my job application, notice that Bonnie, the connection is reestablished.
Is it because it's not deleted permanently?
Yeah, probably it's not really being deleted, it's being marked as is deleted. So yeah, and so I would imagine that there's some sort of, behind the scenes I'm not sure how it's working, but maybe it goes, okay, if there's a lookup relationship and I'm referencing something that is deleted, then do not, for the purpose of the end user, don't display that as a viable link, or
Can
don't.
you permanently delete it?
Oh yeah, so I can go out here and permanently delete Bonnie. I don't dislike Bonnie that much. So if I delete Bonnie,
I think the key is always kept in the job application record.
Yeah.
So even if you delete it, you don't see anything there, but the key is kept there. So when you recover the record with this, or if you can create a new record with the same key, it will be the same thing. Then that name would be shown there.
Well, we could actually test that kind of quickly by going out to
our system. So probably it's working.
We go out to our job application table, and we select the. What we're going to do is we're going to select the candidate field. Where's candidate? There we go. And we are going to say where j dot name equals, and I believe it's app dash 1238, right? So, and just to make sure that I actually got something back, j.id. So, I mean, at least in terms of programmatically, when I run a query, it not only shows on the field blank, but it also shows, in the query, it returns an empty or a null value for that particular field. So I mean, I don't want to spend too much long trying to hypothesize what's going on behind the scenes, but we definitely have some magic elves who are doing some stuff for us. So, okay. All right. Yeah, so, and then, I'm sorry, so, Lyra, getting back to your original question, which is, can you permanently delete? Yeah, so you can empty the recycle bin. You can actually, I'm a system administrator, so I can empty my organization's recycle bin. In other words, all the stuff that other people have created. Or,
but
I'm sorry,
it would
deleted.
be the same behavior. It will be blank, and then it's just you cannot restore the.
Once it's deleted, it is gone.
Right.
Yeah.
So, but the same behavior with the job application, it will just blank out the candidate.
Definitely, yeah. So whether it's in the recycle bin or whether it's permanently deleted, we'll get a null value back for the reference, the foreign key, the ID of the remote record. Okay. Yeah.
What if that field is mandatory? Can you delete?
Then it's going to prevent the delete. So if I if I make that mandatory, it's almost similar to what we did with our roll-up summary. Let me. Why don't I just test that out for you? Okay. All right. Okay. So let's keep moving along here. All right. So we talked about our modifiable system fields. It is not on by default. You need to call Salesforce in order to enable it. The way it works is that you call up Salesforce, you tell them, we're doing a migration, we'd like to utilize the modifiable system fields. They will turn it on for a window of time. It is not something that's turned on forever. It's not a feature like Translation Workbench that's turned on for your org forever. So they'll give you a window of time to perform the migration. They also are able to do things like, if you're performing a migration, relax the limits associated with web service calls per day. So if you're migrating your data, you're going to be doing a lot of web service calls to migrate the data during that week or whatever it may be. They can actually increase those limits for you to perform that, so that you can perform that migration. So,
how is that different than data import?
How is what?
How is that different from data import? There's
oh, let me talk about that when we talk about tools. So there's a import-export feature, and I'll talk about that.
But it's different from that?
Yes, it is. Okay. All right. Yeah, only accessible through the API. You can't do it through the UI. It's compatible with our web services APIs. It says it's restricted to that list of objects, and then it says, and all custom objects. So those are the standard objects that it works with, but it works with every custom object that you create. Okay. Once a record is in our database, it's read-only, or we control it, I should say. Okay. So it's only really for initialization. All right. All right, so let's do some review questions. Who did I leave off on? Lyra, brave volunteer. Name 3 ways you can obtain a records ID.
From the URL,
Yes.
report, and web service API.
Very good. So from a URL, from a report, and from a call to the web services API. Why can it be dangerous to work with a 15-digit case-sensitive form of the record ID? What is the possible issue that we'd run into, Mauricio?
That the legacy system could perform an upcase with a letter sequence, and then when it returns, it wouldn't match the original.
Exactly. Some sort of mangling of the case based on the way that whatever it is that we're storing our data, the database that we're storing our data in, would cause a problem. True or false, the created date can be updated for a record via the API as long as the modifiable system field feature is turned on.
True.
True, or possibly
Or false, I guess.
So the key, there's a word here that makes this false. Update. Anytime we're doing an update, that means we have an existing record. Now, the created date can be inserted. Okay, so if we're doing an insert, we can set or initialize the created date. Okay, so a little bit tricky on the wording there. That's the joy I get. You know, the tricky questions that. All right.
There is one drawback for this time. For example, we are making a data load with, for example, an activity is updated in our legacy system, and now we are trying to load this to the, but this activity still exists in the Salesforce.com. So the updated by and updated date is new in our system, but there is no way we are going to be able to update it in the legacy.
Well, when you actually do the update using the web service call, it will then update the last updated date and the last updated by, or last modified by, So the act of doing the call into the web service to update it, we will then update the last modified date and the last modified by fields based on when you perform the web service call and when or who you use to do that.
So the real updated by and update dates are not going to be in the
so if you do an hourly batch, let's say, of changes, then in your system, the change might have occurred at 10:22 a.m., but if you're running an hourly batch to the call to the web service, at 11 a.m. would be the last modified date, because it would be the date that or the date timestamp would be based on when we did the web service call.
So modifiability is working only if the field is empty, and if you are doing a
yeah, exactly. So that goes, so that's why I was trying to emphasize. It's only when you're initializing those and in doing an insert. So in my opinion, it should be called initializable system fields, not modifiable, because modified to me implies that it's already in there. Okay.
For more information on Salesforce.com training and certification, please visit www.salesforce.com/training.